All right, as promised, here are the notes video. Again, you have a blank version and a filled out version in your folder, so you can use them as you want. But the objective for the day is to be able to find the measures of arcs. Notice that I didn't say the length of arcs, the measures. There's a difference between the two, and hopefully we'll be able to know that difference by the end of the lesson. In any event, a little warm up here. I have a picture of a circle with some lines drawn on it. It says at the right, you see what's called a circle. The center is C. So it wants me to name a diameter. Well, the diameter here, there's only one of those. That is this segment here, starting at A and going to D. So the diameter is segment AD. The radius, that's half the diameter. There's three different radii here. The one that I see here is CB. That is one of them, and that's the segment. Another one is CA. And a third one is CD. Those are all the radii in that picture. Central angle is an angle that occurs at the center. An example of one would be DCB. So angle DCB. Another one I see here is ACB. So central angles are angles that occur at the center. So we'll be using these terms throughout the lesson. So the first thing we'll review, something that you learned in middle school. Those were parts of circles. Again, that's radius, diameter, so on and so forth, central angle. And we're going to apply that to the concept of an arc. Arc, as I said in the first video, is a portion of a circle. And there's two different types. You're going to have a minor arc. This is less than half the circle. So an example of that would be, like, remember Joey was a minor arc. So again, if I have this little guy right here, here's your minor arc right here. If I have an endpoint A and endpoint B, I would name that arc AB. With a little arc symbol above it like that. Major arc, this is more than half the circle. So again, that would be something like this. This over here would be your major arc, which is more than half the circle. Again, if I had the two endpoints A and B, I'd need a point in between to establish that it's a major arc that I'm talking about. I'll call that point C. So I would call this arc in order ACB. Again, you need three letters for a major arc. Or I could also call this BCA. As long as C is between the A and the B, the order of A and B does not matter. Down here, talks about this circle right here, ABC, which is this arc right here, ADC, this arc right here. Those are examples of semicircles. Semicircle is half of the circle. A semicircle is an arc whose endpoints are basically a diameter. So that means that AC must be a diameter. Notice that you need three letters just like a major arc. The reason for that is you don't know which semicircle you're talking about. If I call the semicircle AC, am I talking about this one or am I talking about that one? That's why I have to add that third letter. Each diameter always makes two semicircles. So that's minor, major, and semicircles. Three different types of arcs. All right. So arcs behave just like segments and angles because we have the arc addition postulate, and that's where two small arcs can add to make a big arc. Two small arcs add to make a big arc. So for instance, down here I have this arc ABC, which is kind of made up of two different arcs. You have arc AB, so I'd say the measure of arc AB, plus the measure of arc BC, which is this other arc, makes this whole arc ABC. So two little arcs can make a big arc. Then there's the concept of arc measure. Arc measure, if you remember, is equal to, so arc measure is equal to the central angle that makes the arc. So for example, if I have a circle like this, and then I have a central angle on this, and I say that's 55 degrees. can call this C. So here I would say that the measure of angle C is equal to 55 degrees. So is the measure of arc AB. Notice the little m that's indicating a measure now. That measure of AB is also going to be 55 degrees. So that's what arc measure is, same as the central angle. Keep in mind that semicircles are half of a circle. Their arc measure is going to be half of 360 or 180, which means a whole circle again is going to be 360. And we can use that to find missing arcs. So down here's an example of that situation. So here it wants me to find the measure of arc BD, and you'll notice BD is this arc right here. So that's the third arc of basically making up this semicircle of ACB. So all of these are going to add up to 180. So what I can do is I can do subtract out the 58 and the 32 from 180. So watch how I do that. I would do basically 32 plus 58, and then I do 180 minus that. So you can tell that's going to be a 90-degree arc. Then it wants BC. BC would be the addition of that 90-degree arc, which I just found. So BC would include both of these. So I do 90 plus 32, and that's 122 degrees. Then ACB, well, that's a semicircle, so that's going to be all those arc at 180 degrees. Then arc AC is the same as the central angle, so if the central angle is 58, AC is going to have to be 58. Another example down here. Wants me to find the measure of arc XY. XY is this whole arc right here. Again, the central angle is 56. This arc would have to be 56. So that means XY would be those added together, which is 96 degrees, which is 40 plus 56. Then DXM. DXM is basically this whole arc right here. Well, in DXM, I notice I have 180 degrees here of semicircle, plus this 56. So all I have to do is do 180 plus 56, and that's 236 degrees. So notice I'm using semicircles and 360 to find some of those missing measurements. All right, back here, some practice. Naming central angle. Wants me to name two of them. There's a whole bunch of them in here. An example of one I see is angle FG or FJG. Another one would be like angle DJH. And again, there's a whole bunch of them in there. That's just an example of two of them. Minor arcs. Again, there's a whole bunch of minor arcs in there. I see one at GH is a minor arc. It's less than half the circle. Another one's like ED. Again, there's a whole bunch. That's just an example of two. Semicircle, I got a bunch of those as well. I would probably say semicircle FGH. Another one I see is FEH. So they're examples of two semicircles. Two major arcs, again, bigger than half the circle. You could say FGE. That's a major arc. Another one that I see is arc EGD. So again, that's just an example of two of them. There are more in there, obviously, but that's just one of two of those. Angles in the center of the circle must always add up to 360 degrees for a circle. Angles around the circles, arcs around the circle must also add up to 360 degrees. The arc of a semicircle, again, that's half of the circle, so that's at 180 degrees. That's always going to be true. So down here it says the central angle of a circle is equal to, the whole circle is going to be equal to the central angle of a circle. Oh, is equal to the arc measure. Sorry. So arc measure is always going to be in the degrees as a result of that. So here it wants me to use this circle up here, and it's giving me the measure of an angle here, FJE. That's at 70 degrees right here. I just have a 90-degree marker right there. Then it wants me to find a whole bunch of measurements here. So FE, again, is going to be the same as the central angle, so that would be 70 degrees. DH is a 90-degree arc because it's the same as the central angle. ED, that's the last part of a semicircle here. So basically if I do 70 plus 90, that's 160. And then I'm going to do 180 minus that. So that means this little arc right here is going to be 20 degrees. GH, let's see, I could use this semicircle right here to figure out what that is. Or I could use vertical angles. That was a 70-degree angle, so this would be a 70-degree angle, which means this would be a 70-degree arc. And where's that GH? It's right here at 70 degrees. FG, I could use vertical angles. I could use a semicircle. I could use this semicircle right here. I could subtract out 70 from 180. So again, FGH is 180 degrees minus the 70. So I'm left with 110 on that one. So 110 degrees. EG, geez, that would be what, a semicircle basically? You'd need 3 letters typically to name that, but that's 180 degrees. FGD, FGD is basically a major arc. So FGD is basically the whole thing minus this 90-degree arc. So I'd do 360 minus 90 to figure out what that is, or I could add up all the little arcs. So 360 minus 90, that's 270. So it's 270 degrees. GED, another major arc, that would be the semicircle plus another 20. So 180 plus 20, it's 200. EFH, EFH is a major arc. It is the whole thing minus this, what is that, 110? So I do the whole thing minus 110. So that's 250 degrees. EJD, EJD is an essential angle. It's equal to the arc measure, which is 20. FJD, FJD is equal to 70 plus 20, which is 90. And that's just a misprint. That's also going to be 90 degrees. So here are more practice problems here. I have a 38-degree angle and a 98-degree angle here. I have diameters in FH and EG. They tell me that. So go ahead and find some of these measurements. EF, well, that would be a vertical angle. So arc measure is the same as the central angle. So that would be 38 degrees. DE, well, together these are complementary angles, are 90 degrees, so I could do 90 minus 38 on that one. 90 minus 38, and that's 52 degrees. So this is 52 degrees here. FG then. FG is this arc right here. So I see a semicircle minus this 38-degree arc right here. So that would be 180 minus 38, and that's 142. DHG, that would be this 90-degree arc plus that 38-degree arc. So 90 plus 38, that's 128. DFG, DFG is this major arc right here, which is the semicircle plus a 50-degree arc. So DFG would be 52 plus 180, 232. DGE, DGE is the whole circle, so it's a major arc minus that 50 degrees. So I do 360 minus 50, so that's 310. So down here, one last problem, given the circle, TR is a diameter at 30 inches. Find all the central angles in the diagram. I'm not gonna find them all, but there's a whole bunch of them in there. Angle PZT, if you look in the completed notes, you can find all of them. Angle TZS, etc. There's a whole bunch. The circumference, circumference is equal to what? 2 pi r. So on this one, if the diameter is 30, that would mean my radius is 15. So this would be 2 pi times 15, so that's what? 30 pi. And that's in inches. Lastly, it asks, what's the difference between arc measure and arc length? Remember, this is in degrees. It's the same as the central angle. The length of the arc, that would be like in inches or centimeters or something. That's a length. Again, it's a fraction of the circumference. This is always in degrees because it is an angle. It's the same as the central angle. So there's a big difference between arc measure and arc length, and we focus on arc measure today. Remember that a whole circle is 360. Semicircle is going to be 180 degrees. We talked about minor arcs.